Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 886, possible bipartition. In this video, we are going to explain a method based on traversal. First, I will read through the problem statement to digest the requirement, and then we do some comments and analysis, and finally we share the code. Actually, the code is very short. In some sense. First, the problem statement. We would like to split a group of n people labeled from 1 to n into two groups of any size. Each person may dislike some other people, and they shouldn't go into the same group. So given the integer n and the array dislikes, where dislikes I equals AI BI, indicates that the person labeled AI does not like the person labeled BI. So we need to return true if it's possible to do the splitting. Otherwise, return false. So here are several examples. So in example 1, so the return is true. So you can see the groups, right? So in example 2, the return is false. Actually, this groups forms a chain. So because 1 does not like 2, and 1 does not like 3, but 2 also does not like 3, right? So we cannot do the splitting, so we return false. So similarly, you can interpret example 3. So before we do the further analysis, let's look at the constraints. First, the total number of people is bounded below by 1 and bounded above by 2000. And the length of the array dislikes is bounded below by 0. It means this array can be empty, and bounded above by 10 to the power 4. So this number is a decent large number, I would say. So, and the false item is that the dislikes ij is in between 1 and n, because the persons are labeled from 1 to n inclusive. So here ai is less than bi. So it does actually we can regard it as a bidirectional graph, right? So all the pairs of dislikes are unique. So these are sort of consistent assumptions. So with that said, we are ready to do the analysis. First, we want to see that here the method we are going to explain is based on traversal. Actually, for this problem, we can use both depth first search or breadth first search. So here are some comments. First, so this is actually a graph bipartition problem, which is actually fundamental and important. So it's good to digest the details and make sure we understand and can do the coding for this problem. Secondly, we can interpret this bipartition problem as coloring problem with two distinct colors. So we painting such that neighbors have distinct colors without inconsistency. So this is the second comment. So before we go further, let me make a remark. So we need to notice that the graph in this problem is not necessarily singly connected. For example, below is a test case. So in this example, there are 5 people, and this is the disliked array. So in this example, actually it corresponds to a graph with 2 connected components. So one is 1, 2, and the other is 3, 4, 5. So this 3, 4, 4, 5, and 3, 5 is sort of like in example 2. So we couldn't participate this component. Hence, we shall return false. So this is actually a important case to notice. So here the idea is very natural if we regard this problem as a coloring problem with 2 colors. So we are going to assign a node a certain color, say white, and then its neighbors a different color, say black. So in a cascading way. So if we can do this without inconsistency, we would say, and then we are going to return true. Otherwise, we should return false. So after this video, there will be a follow-up. So the next video will be on Leetcode problem 785. it's actually a direct question. Is graph bipartite? So with that said, we are ready to do the coding. So the coding actually is rather straightforward. So we are going to make this into 3 steps. So the first step, so I'm going to build a graph. So this is actually very standard. So I'm going to use graph. So the collections. So I'm going to use the default dictionary. So let's see, default. So I'm going to use set as the container. So then for AB in this lex. So then what we are going to do is graph A, so at B, means that B is a neighbor of A. Similarly, we want to do graph B at A. It means that A is also neighbor of B. So in other words, so we regard this select relation as a reflexive relation, right? So in the graph language, it means that the edge between AB is bidirectional or undirected. So with that said, we are doing we finished the building of the graph. So next, let's do traversal. So I'm going to do a traversal hyperfunction just to make the code modularized. So for this purpose, I'm going to introduce a dictionary called color. It's going to monitor or record the nodes, the nodes that have been colored. So for this, let me first write the hyperfunction. So traverse. So here we're going to have a source. So which is source can be any person in between 1 labeled in between 1 up to n, right? So here I'm going to use depth first search. So I'm going to use a stack. So this is the source, right? So first I'm going to color a source with a certain number. Let's see, I'm going to use 0 to as 0 as white, right? So I'm going to use 1 as black. See, so you know 1 minus 1 will be 0. 1 minus 0 will be black. This is very convenient. And then we're going to do the standard traversal while loop, while stack. So we're going to get the node. The node will be stack pop, right? So then we are going to check the neighbors of this node. So for neighbor in graph node, then there are 2 cases. First is if neighbor not in color. In other words, the neighbor isn't colored yet. So in this case, so we are going to color this neighbor with an opposite color, that it will be 1 minus the color of the node. So, right. And then we are going to add this one to the stack, that is neighbor. In other case, so the neighbor is colored. So in this case, we are going to check if the neighbor equals the color of the node. So in this case, it corresponds to an inconsistency. So in this case, we are going to return false. So otherwise, we continue, right? So afterwards, if nothing has, if false is not returned, so we're going to return true. So this function actually traverses the connected component containing the source and returns whether this connected component produces inconsistency or not, using 2 color doing the coloring, right? So this is the hyperfunction. So next we're going to write the problem logic, right? Problem logic or check. So for this, so we're going to iterate for I in range. So notice that the people is labeled from 1 to n. So we're going to write range 1. This is the start point, and this is the ending point. The ending point is n, right? Because the red set is not included. So then we are going to check if I in color. So we continue, right? Because it's just colored. It means that all its component, connected component, is colored. So then we are going to do the traversal, right? Traverse this source. So if not temp, it means that the connected component containing I produces inconsistency when we do two coloring. So in this case, we are going to return false, or you can return temp, right? So we are going to return false. So otherwise, if after the for loop, then nothing has returned, so we are going to return true. So this actually forms a solution format for this problem. So before we do any comments or tweaks, let's first do a check. Yeah, it passes the one example. So now let's look at the generic case. Yeah, it passes all the test cases. So here, because here we are using this as a stack, so this traverse is actually depth first search. So if we use pop 0, so this corresponds to using as a queue. Actually, we can test. Sometimes we feel that this can be temp limited. So let's do a check. Yeah, it passes. But if it were temp limited, so we can do this actually. So we can do collections deck. So we can make this a deck, and then do pop left. So this will be a little bit faster. So let's do a check again. Yeah. So anyway, let me recover the original code. So here the source. Here I'm just using pop, and then submit. Yeah. So that's a solution format for this problem. I guess in this video, we first build the graph, and then we route a traversal hyperfunction, and then we do the problem logic or check. So with that said, I guess that's about it for this video. So you are also welcome to check our next video, which is on Leetcode problem 785. Thank you.